Hello. So every measurement will have its associated uncertainty. So for example, somebody did an experiment and measured G to be 9.814 with an associated uncertainty of 0.284 meter per second square. However, if presented like this, it's deemed to be the wrong presentation because there are some conventions to follow. Firstly, the uncertainty is just an estimation, so it deserves only one SF. So instead of 0.284, we are going to write it as 0.3, yeah? 0.3 only. It's just an estimation, so it deserves only one SF. Now, since the uncertainty is written to the nearest 0.1s, so must the measurement itself. So instead of 9.814, we got to round it off to 9.8. So the rule is very simple. The uncertainty, you must round it off to 1 SF. And then you must match the dP. Okay, let's use another example. So somebody measured the refractive index of glass to be so. So again, let's fix the uncertainty first. It's an estimate. It deserves only 1 SF. So 0.01, yeah? 0.01. So now we must match this guy's dP to the same precision. So the precision of the uncertainty is 0.01, isn't it? So this one we must round it off to also to the nearest 0.1. So 1.51. One more example. So this could be the speed of sound, maybe speed of sound. So let's fix the uncertainty first. 1 SF, yeah? 1 SF. So you must round this off to the nearest tens. So you are going to write down 20 as the uncertainty. So now let's match the precision. So this is written to the nearest tens, right? So this guy here must be written to the nearest tens as well. So 340. Okay, we can improve the presentation further by writing this in index form. So instead of 340, you can write 3.4. Yeah, 3.4. times 10 to the power of 2. And then instead of 20, you are going to write 0.2. So you can see quite clearly, right, the rule here. 1 SF for the uncertainty and match the dP. Alright, that's all. Ta-ta!